Hello everyone. In this video, I will show you the workflow to generate files for Homag Panelsaws and 5-sided CNC drilling machines. For the input, I will build the 3D model in Bazis Woodworker. Then, I will use Bazis CNC to export the MPR drilling file for the Homag PTP160 5-sided drilling machine. Use Bazis cutting to export the .ptx file for the panel saw. For the panel saw, it requires Homag link to be activated to receive files from third parties. I use 3 main modules: Woodworker, Cutting, and CNC. I will model a simple product. The dimensions are 900 in width, 750 in height, and 350 in depth. After you open it, this is the interface of Bazis Woodworker. I will select Model and fill in the product information. And click OK. Before I proceed with modeling, I will go to the Current Materials section. Here, I will have the materials. And to add new ones, you select the Edit option. And search for the material codes. For example, I will type it here. And the system will automatically search. Then I click Add to Table. And the system will update. For the active material, whichever material you choose, that is the material you will draw with. For example, here, I will switch to another material. It shows the material I am currently selecting. Then, I will use the vertical panel, horizontal panel, and front panel tools to draw. Alright. I will use these modeling tools: vertical panel, horizontal panel, and front panel, and the tools to set top, bottom, left, and right limits. I will start modeling. First, I will choose a horizontal panel. To change the snap point, press the space key. And to snap to limits within this value range, you can press the tilde key, tilde symbol located below the ESC key on the keyboard. Or you can use the tool to set the top, bottom, left, and right limits. Then you must specify the panels you draw. And to switch between display modes, you can select here. Or use the shortcut key, F3. Now switch to the side view. To navigate, you can hold down the middle mouse button. Or use the shortcut keys. These keys here are for navigation. For example, here I need to navigate to the side view, left and right limits. And if I want to inset a certain edge, you will use this tool. Specify the inset distance. For example, here I need to inset the right edge. Enter the value. Then you position it. To quickly move to each position in the workspace, it will correspond on the coordinate system. And the default unit is millimeters. If you want to move quickly, you can use the cursor step here. For example, if you want 1 millimeter, you can press the up, down, left, right arrow keys on the keyboard. Each press will jump 1 step according to the set values. For example, here I need it to move in 1 millimeter. You left-click or press Enter. The system will automatically create a part. Similarly, you choose the horizontal panel and select the top and bottom limits. Left, right. And note that when you use another command or another panel, you should turn off the limit snapping. To quickly call this cursor step, I will type G like 100. Or I can use the F2 key. For example, if it is 100 here, I will press F2. And I will enter the values. For example, dx equals 0. Enter dy equals 100. The system will jump one step. A jump of 100. Then I will choose the top and bottom front panels. Spacebar to change the snap position. For parts with a grain direction like this, you can click on them. Here you can select the grain direction here. Or in the Properties panel, you can select this item. Here is the model. Next, I will proceed to make groove. As in the drawing, a sliding back panel is used. For the sliding back panel style, I will proceed to route a groove for the back panel part. This grooving tool is a basic operation. I will select Type 2. And I will enter the grooving value here. Then I will select the groove projection plane. Up here in the options, I have along the whole element, so I will click here. Then, with each click, the system will intuitively create a routed groove. If I do not want that, I will have to specify the start and end positions. Then finish. And similarly, I will use this for the top surface of the frame. Finish. This is the operation to create a routed groove. Next, I will draw the back panel. I will switch to the 6mm material. And I will proceed to draw a panel. Select the top, bottom, left, right limits. These back panels. I usually inset them by 1mm on the edges. Site, 63. I will use this limit tool. And I will enter 1mm. Clicking here will copy it to all. Then I will click OK. So I have built the basic frame. When you have built a library, I will have cabinet frames like this. And I will use them much faster when modeling. For example, here I have one system. Instead of drawing from scratch, I will proceed to use this frame. For example, I hide it. To hide a part, select the object and choose Hide Selected. For example, here I can use the standard modules. I have pre-configured the standard modules with information such as grooves and connections. And these modules will dynamically adjust the hardware according to the length of the connection joints. For example, here I will delete and proceed to restore. Right-click and choose Restore. And I will also proceed to draw these vertical panels. Here I haven't changed the material yet, so I will have to click on the active material. And reselect the 17mm thick material. And proceed to position it. Next, I will proceed to draw a door. Draw a door stop rail. Here I have a tool which is an auxiliary line. The shortcut is the X key. And I can create lines with dimensions from relative to this baseline. For example, I draw it at 60. As on the drawing, you can see. At the detail 1 position, it is 60. Then proceed to draw a front panel. Select the top, bottom, left, right limits. And we'll proceed to switch to the side view. Place the part here. Here I will need to draw a notch, and I have custom programmed scripts in script format to quickly perform the notching/cutout operations. Normally otherwise, you would have to double-click the part, and you would draw the contour using the draw contour command. And then I will delete the contour using this command. The shortcut is the T key. And this is a manual operation. For the case where I want to use it, I will choose script. This script. Or create a shortcut. Choose this. Click. I will remove it using a 3mm drill bit. Select. Click. I will have a notch. And there is a drill hole to clear the R at the corner position. Then I will proceed to draw the door. I will choose the door drawing tool. Here I will choose the door overlay method. Here there are options for single door, double door. I will choose a single door, and according to the drawing, I will enter the value. Select material for the door. Select edge banding for the door. Done. Then click OK. And I will proceed to select top limit, bottom, side, and select here. I will drag this part into this door selection. Next, I will model the drawer. I will choose the drawer drawing tool and define the method to determine the height of the drawer. Here, the limit for the drawer part, I will select and choose the corresponding depth. And I will select the type. After that, I will choose settings, number of drawers, and enter the corresponding values, which are the Z1, 2, 3, 4, 5 values. Select material. Select edge banding. And correspondingly, I will choose the material of the drawer box. Select the edge banding data. Then click OK. I will get 3 drawers with connections. And the next step is I will proceed to copy. I have the door stop rail here. And I will copy. You can use the copy by point commands. Done. The next step after I have modeled, I will proceed to add fasteners and apply edge banding. The edge banding operation is as follows. Step 1 is I will go to the select section. Select by material, or you can use the shortcut key. Step 2 is I will tick the material I want to apply edge banding to. Then in the Properties section, and select the item. Edge banding. You can select edge banding at the edge banding options here. And I will select. And here I will select replace. This is the edge banding operation for the parts. For the parts, the positions that are in contact with each other, the system will not apply edge banding. Next step, I will proceed to add connections. Before adding connections, I will hide the part. Then I will proceed to select the parts that need connections added. For example, here I know that these parts short connection joint schema, so I will select it. And the highlighted positions are the connection joints. To change them, you select Properties. and I will select the appropriate connection schema. For example, here I will select. Then you choose Install. If this joint does not have a connection, you click Exit command. Similarly, for the large joints, you will select and change to another connection schema. To see the connection steps, you click on this option. Then you install. To change the face, point at the joint and press the middle mouse button, or specify it in the Properties section. There is an item for main face direction. Install. Next, I will proceed to add connections for the door. You choose similarly. And here I will select hinge schema. Install. And then I will proceed to cut the panels. Select. Click Place Positions again. And save the file. And I will proceed to cut the panels. To export the PTP and drilling files. To switch to panel cutting data, you click on the icon, Bazis Cutting. And to proceed to export the drilling file for the Homag machine, you will proceed to click on the CNC section. For the Bazis CNC part, you will select the post-processor as Homag Woodwop. In this box, you scroll down. There will be an item. There are many different machine series. You will select Woodwop. As for panel cutting, you will select for me the post-processor, which is Holzma. You will tick the item Holzma. After those sets, you click OK. So the operation, I return to the operation of exporting files so that while I load other data, I will proceed to export files. To save time, here is the export file option. You can load the configuration. For example, here I will select Load Configuration and save the configuration. So when I save the configuration, for example, I save the configuration here. And for another machine, you just choose the configuration and the settings will be loaded. Then I will proceed to export the file. Exporting the file, I will obtain the drilling files correspondingly here. For these files, you will copy them to the PTP160 CNC machine. With the option here, I will proceed to configure. Here I will select the Holzma configuration in the post-processor section and proceed to cut. The settings here, you can also save and restore. And I will proceed to cut. Select one. Cut here. Select material. For example, here I have two types, so I will proceed to cut them both. Homag machines that support real-time label printing. You will set up the real-time label printing part. Whenever you cut a part, it will output the label for that part. After the system finishes cutting, it will switch to the preview interface. In this interface, check the map, cutting map arrangement, and print labels. This is the interface. And to preview the label part, you can click on the print label icon. Or in cases where you print labels manually, you will select the label printing section. And I will click print label again. And proceed to preview. This is the data, the label templates with QR codes for scanning correspondingly. and, when I accept the data, the system will automatically generate the report profiles and the program's automated file dump in the format of .ptx extension file. Here, this is the .ptx file. You will copy this entire folder into the Panelsaw machine, and when you import it on the machine, the system will automatically convert the layout maps and corresponding label programs so that it can automatically print labels in real time. And here is the report profile. So you will click Print. I will proceed to print the report profiles. In here there will be statistics related to the map, statistics related to the parts list. I will proceed to print. I will save it. These are the information. Statistics. Statistics. So I have introduced to you the steps to output files for the machine series, the Panelsaw from Homag, point-to-point 5-sided drilling machine. Thank you for watching.